Exercise 11. Today we're going to talk about interpolation and extrapolation. So we're going to start with an example. It says, consider the following graph. So pretty basic here. Someone's selling a bunch of t-shirts, and as they sell t-shirts, they make a profit, right? They make money. That's how it works. You sell stuff, you make stuff. So we've got some questions here about reading the graph. First question, how much money do you earn by selling 20 t-shirts? Okay, number of t-shirts at the bottom. Here's 20 right here. So I go straight up until I hit the graph, and then I go over from there, and then we estimate how much that is. Well, it's more than halfway. Halfway would be 75. It's a little bit more. I would say 80 bucks probably. Do I know that 100%? No, but that's my best estimate from this graph. Okay, how much money? Oh, and by the way, notice that that is one of the actual points. Like, it looks like they got some data, right? They found out, I'm just going to make a little table. Maybe I should have done it this way. Number of shirts and profit. And that's in dollars. And if you look, there's only 4 points that they actually had here. It looks like when 20 shirts were sold, they made $80. And what else we got? When 40 shirts were made, when 60 shirts were made, and when 80 shirts were made. Are we able to figure out the amounts? For 40, it looks it's about 160. When it's 60, it's close to 250, but not quite, maybe 240. And for 80, it's a little bit more than 300. We'll say 320. So there was only actually 4 points that they graphed. And the first question, I asked you one of those 4 points. For the second question, I don't ask you one of those. I don't ask you 20, 40, 60, or 80. I ask you what 50 is. Okay? This is what interpolation is called. I'm going to define it in a minute, but I'll just tell you right now that when you're trying to find some data that falls within the points that you already know, that's called interpolation. So 50 t-shirts, let's do this. 50 would be where? Well, there's 40, there's 60. 50 would be right in the middle. And then if I go straight up from there, I should really use a ruler, shouldn't I? I think I hit right there. I think I hit right in the line. So it looks like we're exactly at 200. So I just interpolated. Again, the reason I interpolated is because this value, 50 shirts, was not one of the original 4 data points, but I can use the graph to figure out how much it would be, and I find that it is $200. Okay, next question. How much money do you earn by selling 120 t-shirts? Okay, now we have a problem. 120 t-shirts, look, our graph only goes up to 80. How are we going to figure out how much 120 is? You're going to have to extend the graph. This is called extrapolation. When you try to estimate something, some data that falls outside of the points you already know, right? The biggest point we knew was 80, and we want to know what it is for 120. That's beyond the graph. So what we do is we extend the graph. So let's see what we can do here. 20, 40, 60, 80. So I guess this is going to go to 100, and then this is going to go to 120, and that's the value we want right there is 120. Now the other thing I have to do is extend this line here. I'm going to make a nice straight line this time. Okay, there. I've actually drawn right over the original line just to make sure I have it exactly the same size there. So there you go. I can now figure it out for 120. I go down to 120 t-shirts. I go straight up from there. Ooh, not a bad straight line. Gets to about here. And then I go over from there. I don't know, it's about here. So let's see, we had 450 here. This would be 500. This isn't quite halfway. Halfway would be 475. So maybe around 470 or something like that. I actually think that's not the right answer because I think I know what the actual answer is. But you know what? It's a pretty good estimate. I'm going to accept it. 470. I think it's actually 480, but that's not what my graph actually looks like here. All right, these are estimates. We should be getting close, but we might not get it exactly correct. If you made $280, how many shirts did you sell? So now we're doing the opposite procedure, right? They give us the profit, and we have to figure out the shirts. Up until now, they've always given us the number of shirts, and we figured out profit. Now they're giving us profit, 280, and we got to figure out shirts. Well, the first question, 280, would be right around where? 250, 275 would be right in the middle. 280 would be a little bit higher, be right around there. So then I go over from there, the 280, to the green line, and then down from there, and I think it's right in the middle, isn't it? More or less. So between 60 and 80 would be 70 t-shirts. So question for you, what I just did right there, was that interpolation or extrapolation? That was within the data points I knew. I didn't have to extend the graph at all, so that was interpolation. Okay, again, I should probably have defined these before I start writing all this down, interpolation and extrapolation, but hopefully you're figuring it out, and I will define it in a second. Okay, if you made $8, $8, that's pathetic. How many shirts did you sell? Well, $8 is where? Somewhere, here's 50, here's 25, 12 and a half, I don't know, it's right around there is $8. So how many shirts is that? Well, that's beyond the range of our graph again, isn't it? This must be another example of extrapolation, because we're going to have to extend that graph a little bit. So let me do that right now, extend the green line even further, right down to the left-hand side. Okay, this is a very awkward example. You see my dot is just a little bit above the line, so basically you'd move over like that tiniest little bit, and then you'd come down from there, and that's whatever that point is right there, that's how many shirts you must have sold. Well, halfway would be 10, another halfway would be 5, looks like it's a tiny bit less than that. I don't know, 2 or 3 shirts I would say. We are estimating here, but I would say around 2 or 3 shirts is how many that you must have sold to get $8. Kind of a bad example, it's just too smushed in here, you can't really see it very well. But I'm hoping you got the idea. Alright, so finally let's define these two words. Interpolation is when you estimate a value that falls within, that's the key word here, within a known range or graph of values. So for example, again, I'll just look back for a second here. It was interpolation when we were talking about selling 50 t-shirts, because 50 was, here's 50, it's within the data that we already knew. But extrapolation is when you're estimating a value that falls outside a known range of graphs, or, that should say or. So estimate a value that falls outside a known range or graph of values. So back here again, the reason it's extrapolation for 120 t-shirts is because 120 t-shirts was not within our data points, right? We had to increase the line. We had to add to the line. Our data points ended right here, and 120 was beyond that. There you go. Hope that makes sense. Now, which one of those two things, interpolation or extrapolation, which one do you think is more reliable? Or which one do you think is less reliable? Extrapolation is less reliable. Why would that be? Well, let's just think about this for a second. If I had a whole bunch of points, point, let's pretend this is a graph of some sort, and then there's this space and it keeps going here like this, okay? What do you think is more reliable? Saying, when I look at these data points, I think there must be a data point right there. That seems pretty reliable, right? It's not for sure, because maybe this thing would go like this and then down like this, and then but that's not very common that things act like that. What's very common is when data points look like this, it just continues in a straight line all through it like this. So this would be interpolation because the red dot is within the dots we already knew. Now, with extrapolation, you might also guess that I could extend this. It goes like this, it goes like this, it goes like this. In other words, the trend continues. But here's the thing. Sometimes in life, things don't continue onwards like this. Think about this as a plant growing. Okay, so the plant's growing, it's getting taller and taller, and we now guess it would be this tall at a certain time, and then this tall and this tall and this tall. Is it safe to assume the plant's just going to keep going taller and taller and taller and taller? No. You know what happens when things keep growing and growing? They start growing slower and slower and slower, and then eventually they don't grow at all. They just stay the same height. So it would actually go like this. So if you're guessing that the thing goes like this, you'd actually be wrong. So extrapolation is a guess, so is interpolation, but interpolation is more reliable because it's between data points we already know. If you go outside the data points, like extrapolation, either up here or down here, then you're taking a risk that the trend might not actually continue beyond the extremes you already know. All right, last question about Corey playing baseball. His coach records the speed of his outfield throws and the distance the ball travels. So he's throwing the ball at different speeds, and then we're seeing how far he throws the ball at those speeds. You would think that higher speed means further distance, and I think that's what we find here. All right, so let's graph this data. Now, remember, the independent variable goes in the bottom. Which one's independent? Is the speed, can he control that? Or can he control the distance once it's released from his hand? He can control the speed. The distance depends on the speed thrown. So speed goes down here. Here's another thing. If you have a chart, like we have here, a table, if it's made properly, they should always put the independent one in the left-hand side of the table and the dependent one on the right-hand side. And then remember, independent goes on the x-axis and dependent goes on the y-axis. So your distance would be here. I guess we can put meters here. We can put kilometers an hour down there. Okay, what's our speed need to go? We need to go all the way up to 85, and actually we've got a question about 87 here, so we've got to go all the way up to 87. But here's the thing, we don't really want to start, we'll talk more about making graphs later, soon, but we don't really want to start at 0 and go 10, 20, 30, 40, 50, 60, 70, 80, or all our points are going to be squished together. So, do you remember, and again we'll talk about this soon, you can do that like broken line thing, and I can start wherever I want. So why don't we start actually at 70, and then go up by 2. 72, 74, 76, 78, 80, 82, 84, 86, 88, and 90. Okay, then for distance, we've got to get up to at least 57, probably a little bit higher. Maybe we could break this one too. I know it looks a little awkward in the corner, but don't start at 0 again. Let's start at 38 and go up by 2. I hope that works. 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, and 60. That should be okay, I think. So let's graph this. We've got one point at 70, 39. So here's 70, and then 39 would be halfway between 38 and 40, so right there. Our next point would be at 72 and 40. Then we've got 75, which would be here, and 44. 44 is way up here. 80 and 49. 80's here, and 49 is right there. 83 is between 82 and 84, and we got to go up to 54, which is way up here, right there. And 85 and 57. 85 and 57 would be here. Okay, there's our points. Now, here's the first thing to realize. They don't all line up in a perfect line. It's nice when questions do. You know, like this one here, it was perfect straight line. You know what? In real life, things usually don't land up with perfect straight lines. So what you have to do is you have to do a line of best fit. You have to draw the best straight line you can here. So I'll give it a shot. What do you think? Not bad. It goes through this one and this one, more or less. Just misses this one. We've got two of them which are a little bit too high, and one of them is a fair bit too low. I think that's pretty good, though. I think that's not a bad graph right there. All right, how far would the ball travel if Corey threw it at a speed of 87 kilometers an hour? So 87 is right here. Here's 87. So in order to do this, we want to go straight up from there. I'm actually going to use straight lines here to do it correctly. Straight up from there. And then we need to go over from that point, from the line over here. So let's see. 58 was here. 60 is here, so 59 would be in the middle. And this is a little bit more than 59. You could probably estimate 59. I'll go 59.2. I don't know. 59.2 kilometers an hour. How far would the ball travel if Corey threw at a speed of 77 kilometers an hour? So 77 is here. So let me get my lines again. If I go from 77 straight up to our graph, it hits right about there. And then if I move over from there, whoa, it's really close to 46, isn't it? This is 46, 48's there. It'd be nice if I drew my numbers a little more accurately, but this is 46. It's a little bit more than that, so maybe 46.1, 46.2. Something like that. You could probably estimate at 46, but I'll say 46.1 kilometers an hour. Now, one of those questions was interpolation, one of those was extrapolation. How do you tell? Look at the extremes we knew. The extremes we knew were, the smallest we knew was this point here, when the speed was 70. And the biggest we knew was this one when the speed was 85. So which one of those points that we just found fell within those yellow lines, those yellow circles? That was this one, right? That was within the yellow circles. So this was interpolation. That was the one at 77. 77 was interpolation. But this one, way up here, this one falls outside our circles. It's beyond this circle here. So this is extrapolation. That is the one at 87 was extrapolation. So that was B. Question B was extrapolation. And so it makes it just a little bit less reliable. Who knows, maybe when you get to a certain speed, maybe for one thing he can't throw any higher than that. Maybe his top end speed is right here. So it's unrealistic to talk about him throwing that fast. Or maybe something to do with the air resistance or something. There's a maximum that's possible and this thing starts tailing off like that. This one's very reliable, right? It's right in the middle of our points. But this point up there isn't quite as reliable. Extrapolation. Hey, just for fun, let's find the slope, right? We don't want to forget things we already know. Pick any 2 points on this graph. Well, why not pick this one, which seems to be right on the graph, and this one, which also seems to be right on the graph? So then we need to find the rise, and we need to find the run. Now be careful. This one went from 75, this was at 75, I'll just put 75 here, and it went all the way up to 83. So 75 to 83 means a difference of 8. Our run is 8. Now this way we started at 44, I know that looks like 94, it's 44, and we went up to 54. Well, 44 to 54 is 10. So there's our rise and there's our run. So our slope, I should have put this question on, it's a good question, is 10 over 8. You could put that in lowest terms, divide them both by 2, 5 over 4. Or if we want as a decimal, 5 divided by 4, 1.25. Hey, you know what else we could find? What's the rate of change? Remember, rate of change is just the same as slope. So it'd be 1.25. But 1.25 what? Meters per kilometers an hour. That's weird, but it actually is what it is. 1.25 meters per kilometer an hour. That means for every extra kilometer an hour he throws the ball is going to travel another 1.25 meters. All right, I hope I didn't confuse you with that, but I like bringing back stuff we've already learned in the course. Take care, everyone.